I welcome you to this lesson. I'm teacher Katimbo Richard, teaching mathematics P6. And again, I welcome you to second term work. And today we are discussing fractions. And as you remember, in the previous class, you did fractions. Teacher told you a fraction is a part of a whole, and taught you the four types of fractions. Told you the first one is a proper fraction, which proper fraction is also known as common fraction or a vulgar fraction. And told you a common fraction is that one that has got a numerator that is less than the denominator, like 9 out of 10, 3 out of 4, that's 3 quarters, a half, which is written as 1 out of 2. So long as the numerator, that's the upper number, is less than the denominator, that is a common fraction. The other type he talked about was an improper fraction, which is the opposite of proper, where the upper number called numerator is less than the down one called the denominator. He gave you examples like 3 out of 2, like 6 out of 5, like 10 out of 3, so long as the numerator is greater than a denominator. And then he taught you about mixed fractions, where a mixed fraction is that one that bears a whole and a common fraction, and gave you examples like 3 and a half, 4 and a quarter, so long as I've got a whole and a proper fraction, that is called a mixed fraction. Then he taught you about decimal fractions. Those are fractions that contain a decimal point, like 0.4, like 2.9, like 9.2, so long as there's a point in between there, which contains a point, that is a decimal. And you did a lot in that area. Majorly in P6, we look at the four operations, that is addition, subtraction, multiplication and division of fractions, as well as the application of fractions in day-to-day life. So that's why teacher now comes with the four operations or fractions, starting with addition and subtraction of fractions. And after the discussion of today's lesson, you will be able to answer all the activities ranging from page 1 to 8 of your workbook. That is term 2 or P6 work. As I said, we are starting with addition and subtraction of fractions, and please follow strictly to be able to answer the work on the said pages of 1 up to 8. So number 1, for example, number 1 says add 3 out of 4 plus 1 over 9, or add 3 quarters plus a ninth. In addition of fractions of different denominators, we normally use LCM. And in previous class, that's P5, you must have learned how to find LCM. You can then determine the LCM of 4 and 9 as 36. So LCM of 4 and 9 is 36, as we learned in the previous class, P5. So we multiply each of these. That's 3 quarters and a ninth by 36, then out of 36. So you say 3 out of 4 times 36, brackets, plus 1 out of 9 times 36, also in brackets, out of 36, which is LCM. And now we do our cancellations. 4 by 4 ones, 36 by 4 get 9. Then you go 9 by 9 ones, 36 by 9, you get 4. You make 3 times 9, which is that 27, and then 1 times 4, which is a 4, out of our 36. So we add these two, 27 plus 4, you get 31. out of our 36. In so doing, we have added 3/4 and a ninth to get 31 out of 36. 31 36, or 31 out of 36. By mere determining the LCM, multiply each of these by 36 and then out of 36. Cancel well, multiply, get the outcome, and conclude. 31 out of 36 is the answer when you add 3/4 and a ninth. Then example 2 says simplify 2/3, 2 whole numbers at 1 out of 3 plus 1 and 2/5, or 1 whole number 2 out of 5. Now addition of mixed fractions. Addition of mixed fractions. In P4 and 5, you learned how to convert mixed fractions to improper fractions by getting the denominator times the whole number plus numerator out of denominator. I said denominator times whole number plus numerator out of denominator. So we convert them first to that form, which is improper form. That 3 times 2 is the 6 plus 1 is the 7 out of 3. That's why I've got 7 out of 3. Then we go 5 times 1 is the 5 plus 2 is the 7 out of 5. That's why I've got 7 out of 5. So the new ones are 7 out of 3 plus 7 out of 5. 7 thirds plus 7 fifths. Whose LCM? LCM is for denominators. Lowest common multiple of 3 and 5 is 15. So multiply each of these by 15 like we did in the number before. That's number 1. That is multiply this and this each by 15 out of 15. So we go 7 out of 3 times 15 in brackets plus 7 out of 5 times 15 in brackets out of 15. And now we do our cancellations. So we say 3 divided by 3 is 1, 15 divided by 3 is a 5. 5 divided by 5 once, and 15 divided by 5 get a 3. You get our 7 times 5 as 35, and then 7 times 3 as 21 out of 15. And now I'm going to add, actually, 35 plus 21. Add well, you get 56. 56 out of 15. Now I've got 56 out of 15. Which form of fraction is improper? So improper fractions will never make answers in mathematics, apart from when it is reciprocal. But now this is not reciprocal. They are telling us to add fractions. So in addition or in any form of fractions, even if it is multiplication or division or subtraction, the improper form will never make an improper, will never form a proper answer. It makes an improper answer. So let us get what is called a proper answer by dividing 56 by 15. Should be noted that 15 out of 15, it should be noted that 56 out of 15 means 56 divided by 15. So we are going to divide 56 by 15. The question is, how many 15s are in 56? Then you are required to count in 15s, where the first 15 is a 15, plus 15 you get 30, plus 15 you get 45. When you add on 15 you go 60, which is beyond 56. So we take 3 of them, add 4 of them. So 15, 30, 45. So 56 divided by 15, there are 3 15s. Then get a remainder by subtracting that 56 minus 45. 56 minus 45, you will get 11. So 56 divided by 15 is 3 remainder 11. With 3 remainder 11 is going to form a mixed fraction, which is 3 whole numbers 11 out of 15. 3 whole numbers 11 out of 15, or 3 and 11 15ths. I said 3 and 11 15ths. So that is the answer. Finally, whenever you get out an improper fraction, please divide the numerator by the denominator. You will get a whole and a remainder, which whole is written like you are seeing 3 remainder 11. That's 3 whole numbers 11 out of 15. And that's the answer to this question. That's how one adds the mixed fractions. As we can go to the alternative. If one did not add like this, then one would add like this. Here, in this alternative, you are going to add the whole numbers first, and then the other proper fractions. So 2 plus 1, then plus a third, then plus the other last one, 2 out of 5. This is what's done. 2 plus 1, the whole numbers first, then a third, and 2/5 last. So, where 2 plus 1 is a 3. And now here, determine the LCM of 3 and 5. So LCM of 3 and 5 is 15. So we, as usual, multiply a third by 15 and 2/5 by 15 out of 15. A third times 15 in brackets plus 2/5 times 15 in brackets then out of 15. And now we cancel by 3 ones by 3. That's 15 divided by 3, get 5. 5 divided by 5 divided by 5 is 1. And 15 divided by 5 you get a 3. So we multiply properly. That is 1 times 5 you get 5. And then 2 times 3 is a 6 out of 15. So remember, the whole numbers brought a 3. That's a 3 that's waiting for the outcome of the other fractions. So I've got 5 plus 6 out of 15, which 5 plus 6 and 11. So that's 11 out of 15. So 3 whole numbers plus 11 out of 15, thereby getting the same answer like we got before. That's 3 whole numbers, 11 out of 15. So you have freedom to choose between the two kinds of working. Here you can use the upper one, where we first convert a mixed fraction to improper before we add normally, and then convert to a mixed fraction thereafter. Or add the whole numbers first, 2 and 1, to get a 3, and add the other one separately. Thereby mixing them later to get 3 whole numbers and 11 out of 15, like we got before. So there's no problem whatsoever if one chose any of the two. So look at the third example. Remember, the subtopic was addition and subtraction of fractions. We have done the addition, so we go to the subtraction. Number 3, that's example number 3 says, or tells you to subtract 4 out of 5 minus 1 out of 2. Technically read as 4/5 minus a half. 4/5 minus a half. Like we did in addition, like we do in subtraction. Determine the LCM of the denominators, that's 5 and 2. So which is 10. So you say LCM of 5 and 2 is a 10. Multiply the first and the second each by 5, by LCM 10 out of the 10. So we go 4 out of 10 times 10 in brackets minus a half times 10 in brackets out of 10. Then go into our cancellation. The difference is only the minus sign of subtraction. That is between addition and subtraction here. So we work out the same way, but here we use the minus sign of subtraction. We say by 5 once. That is 10 divided by 5 is a 2. 2 divided by 2 is a 1, and 10 divided by 2 you get a 5 out of our 10. Where 4 times 2 you get an 8 in minus. Remember it's a minus. 1 times 5 you get a 5 out of 10. Where 8 minus 5 is a 3 out of 10. In so doing, we have done the subtraction as instructed. So you have got the answer, 3 out of 10. Remember to use the minus sign of subtraction as opposed to a plus sign of addition for the other two examples we looked at before. As we look at subtraction of mixed fractions. Subtraction of mixed fraction. So that is subtract 6 and a 5 minus 3 and 2/3. Subtract 2 and a 5 minus 3 and 2/3. Like we did it before, we convert each of these mixed fractions to improper fractions. Remember, it is denominator times whole number plus numerator out of denominator. So do we multiply and add out of the denominator. That is 5 times 6, which is 30. Which is 30 plus 1 gets 31 out of 5. Then go minus We convert the other mixed fraction as well. That is 3 times 3 is a 9, which 9 plus 2, you get an 11, which 11 is out of 3. That's the improper form from the mixed fraction. Now I've got two denominators of 5 and 3, whose LCM is 15. So we multiply each of these two by the 15 out of the whole 15. So we say 31 out of 5 times 15 in brackets minus 11 out of 3 times 15 in brackets out of 15. Before we go into our cancellations, we go 5 divided by 5 is 1. 15 divided by 5, you get a 3. And now I've got 3 divided by 3 is a 1. Where 15 divided by 3, you get a 5. Thereby remaining with 31 times 3, multiply well. 31 times 3, you get a 93. And now put a minus, and 11 times 5, you get 55. Thereby having 93 minus 55 out of 15. And now subtract now side work. We want to determine the accuracy of the difference between 93 and 15. So write 93 above 55, brother. The difference between 93 and 55, you write 93 above 55, and then subtract normally, that is in their corresponding place values. Now, 3 minus 5, why is it known that we cannot subtract unless we borrow? We borrow from 9 and get 8. And now, or remaining with 8, which borrowed one is called 10. 10 plus 3, you get 13 now. 13 minus 5, you get an 8. And that 8 minus 5, you get a 3. So I've got 38 when we subtract accurately. So on top I've got 38 out of 15. And I remember to have told you that any proper fraction will never make a proper answer in mathematics. So it makes an improper answer. Whereas we want a proper answer out of the subtraction here. So again say 38 out of 15 means 38 divided by 15. So now divide 38 by 15. We are counting 15s. 15, that's 15 times 1 is 15. 15 times 2 is 30. So this 38, you see that the remainder is 8. So it goes 2 times and the remainder is 8. So 38 divided by 15 is 2, remainder 8. Which 2 makes a whole number and 8 makes a fraction. So that is 2 whole numbers, 8 out of 15. So you have successfully subtracted those 2 mixed numbers. That's how we subtract the mixed numbers like we did the addition. Be perfect for your teacher is. So we go to another operation. We have so far looked at 2 operations on fractions. That's addition and subtraction. Now we go to the third operation, which is multiplication of fractions. And here are the examples. Example number 1 says, find a third of 3/7. Find a third of 3/7. In the previous class 3/5, you learned the meaning of. It means the times sign of multiplication. So replace the of with the times sign of multiplication. That's a third times 3 out of 7. It is in multiplication where we can actually cancel before anything is done on sight of a common divisor. On sight of a common divisor, you will see that we have got a 3 up and a 3 down. Then those 2 3's can able be divisible by 3. So you can first divide before you even multiply. We say 3 divided by 3 is a 1, and 3 divided by 3 is a 1. Thereby remaining with 1 times 1 out of 1 times 7. Here you must note that in multiplication of fractions, we consider multiplying numerators first and then denominators last. So here we don't opt for LCM method. We multiply the upper numbers called numerators alone, then denominators later, and then the outcome will be the answer. Thus, we say 1 times 1 is a 1, and 1 times 7 you get a 7, thereby leading to a 7th, and that's all, nothing else. So we don't use LCM in multiplication of fractions. We only consider multiplying the numerators first, then the denominators last, and then get the answer. Like we've got 1 times 1 as 1, 1 times 7 as 7. thereby getting a 7th as a conclusive answer. Ensure you look at the 2, that's the numerator and the denominator, before you conclude as the answer, because you must look at the divisibility of those 2. If they are still divisible, meaning reducible, please reduce. But this is in its simplest form a 7th, so continue. So you write a 7th as a conclusive answer in that number. Before we look at example number 2 that reads, simplify an 8th times 5/5. An 8th times 4/5 rather. An 8th times 4/5. Now, like we said, we will rewrite it. We say an 8th or 1 out of 8 times 4 out of 5. We look out for the common divisor. Look at the numerators and denominators. If one is a multiple of the other, then it means you need to reduce or cancel first. Like I've got 4 on top, meaning as a numerator, and 8 as a denominator. This is 4 and 8, or this is 2, 4 and 8 can ably be divisible by 4. That's why you first reduced or cancelled by 4. By 4, 4 divided by 4 is the 1, and 8 divided by 4 is the 2. Thereby remaining with these 2 numerators of 1 and 1, and 2 denominators of 2 and 5. And multiplication, I said, multiply the numerators first, and then the denominators. So we write 1 times 1 as you see here, and then 2 times 5 here. Then do multiply as instructed, where 1 times 1 is the 1, 2 times 5 is a 10, thereby leading to a 10th, which is already a reduced fraction, and that's the answer. Just get your ruler and underline and nothing else. So you have got all the maximum marks. Now, there's when they will not tell you to multiply directly, but they will bring a number which is wordy. A wordy number, one called word problems involving fractions of multiplication. So we look at this not as a problem, but as a word number, a number containing words which will call for multiplication of fractions. Now, you must then not fear numbers concerning words, because they are the easiest when understood. Let us see. There's one Ozuru. There's one called Azuru. Azuru bought 3/4 liters of milk. Okay, good. Azuru bought 3/4 liters of milk. Okay. He drank a third of the milk. You see that word of? It must be looked at keenly. He drank a third of the milk. Good. How much milk did he drink? How much milk did he drink? They will ask you, how much milk? Of course, milk is measured in liters. So how many liters of milk did he drink? It's the same as how much milk did he drink. You must consider the word of. This is like this number here. He drank a third of the milk, which milk was 3/4. It's the same as find a third of 3/4. Find a third of 3/4. He drank a third of the milk, which milk was 3/4. So you say a third of 3/4. A third of 3/4. Don't you see? You fear for nothing and leave a gap and leave those marks to the examiner, which is very, very bad. We go a third of 3/4, just like that. Which of is interpreted as in times. We say a third times 3/4. So we go by 3, divide by 3 once, divide by 3 once, because these two are divisible, thereby remaining with 1 times 1 out of 1 times 4. Which step is that one? Where 1 times 1 is a 1, and 1 times 4, you get a 4. So this, Azuru drank a 1/4 liter of milk. That's a 1/4 or a liter of the milk. That is how much milk this Azuru drank. All in all, never fear word numbers, because they are very easy. That is if you understand the key words, like teacher has taught you now, the key words of. He drank a 1/4 of 3/4. Sorry, a third of 3/4. he drank a third of 3/4. It's the one used here, and which when used, you will find out that this Azul drank a quarter-liter of the said milk, and it's nothing else. You will score 4 to 5 marks on just comprehending this number. You must really understand. Choose the rightful operation here. This off will tell you are going to use multiplication operation. That's a third times 3/4 to answer that number and nothing else. As we look at number 4, which is also wording, please, you must read to opt for the operation that is right among the 4 operations. So we go. Number 4, a construction firm or company builds 2 and 4/5 kilometers each month. Oh, it is constructing roads. Okay, if it takes 2.5 months to complete the road, okay, how big is the road? Remember, each month this construction company or firm builds 2 and 2/5 kilometers and takes 2.5 months. Oh, every month is this one. What about in 2.5 months? Meaning you are going to multiply this 2.5 by 2 and 4/5. I say multiply 2.5 by 2 and 4 out of 5. Answer will be in kilometers because they are asking for how long, the length of the road. The length of the road. How big, how long is the road? The length of the road in kilometers. So here they want the length. How long? It's even better for it to be in length. The length of the road in kilometers. So how long is the road? So each month, this construction company or firm builds 2 and 4 out of 5. That's 2 and 4/5 kilometers of the road, and takes 2.5 months to complete that road. Find the length of the road. You multiply 2.5 by 2 and 4/5. That is 2.5 times 2 and 4/5. Like I said, we convert this mixed number to improper fraction. That's 2 times 2 plus 1. That's 2 times 2, 4 plus 1, you get 5 out of 2. 2 times 5, the 10 plus 4, you get 14 out of 5. Then multiply 5 out of 2 times 14 out of 5. Look out for the common divisor. You see, we've got 5 and 5 down, so we can able divide 5 by 5. So by 5 once, by 5 once. Then, so do we have 14 and 2? They are both divisible by 2. So 2 divided by 2 is 1, and then 14 divided by 2 is 7. You remain with 1 times 7 out of 1 times 1. So 1 times 7 is a 7, and 1 times 1 is a 1, where 7 is divided by 1 to get a 7-kilometer road. So the length of the road was that 7 kilometers. All in all, you must know how to read and then choose the rightful operation to be used. Here, it is multiplication. So each month, this construction company builds a road as long as 2 and 4 out of 5 kilometers. That's 2 4/5 kilometers. But it takes 2.5 months to complete the whole road. How long was it? It was 7 kilometers long, and it's got by that multiplication operation chosen among the other 3. So then we go to number 5. It's about words also, and let's see what brings on board. Find the reciprocal of 2/3. Find the reciprocal of 2/3. You must know the word reciprocal and must have learned it in P5, but now it has come the application of multiplication operation. You must know. Teacher taught you the meaning of reciprocal. Reciprocal in mathematics when you go to English, it means the opposite or the reverse. So the reverse of the numerator becomes a denominator, and the denominator becomes a numerator, meaning you write upside down. For example, 2/3, the reciprocal will be 3 out of 2, or 3 halves. When I've got 4 out of 5, the reciprocal will be 5 out of 4. So the opposite, if it is 3 out of 10, the reciprocal will be 10 out of 3. The other way around, the opposite, the reverse. So they will say, in your analogies, in your English, they will say, opposite is to English as dash is to mathematics. You say opposite is to English as reciprocal is to mathematics. So in mathematics, our opposite is called reciprocal because we deal with figures. Now, we have learned that reciprocal means the opposite, where the down number called denominator becomes the numerator and vice versa. But much of that is so, mathematics has got a kind of working for every number. We don't just pick it upside down, like we've got 2/3, you know the answer 3 halves, meaning 3 out of 2. Don't just pick it upside down like you have heard the teacher say. No, there must be working. Mathematics is about working and proved working, which is universal. So what's the law or the rule about reciprocal, or the working about reciprocal? It is like this. The product of a fraction and its reciprocal is 1. You must know the product of a fraction and its reciprocal is 1. Meaning, when a fraction is multiplied by its reciprocal, 1 gets 1. So that's why you say, let the reciprocal, you are talking about BM. Let the reciprocal BM. Before that, I must note that reciprocal is also known as multiplicative inverse. When I say find the multiplicative inverse of 2/3, I will be meaning find the reciprocal of 2/3. When I say reciprocal, I'll be meaning multiplicative inverse. So when you hear the word multiplicative inverse, or you see multiplicative inverse, they will be asking for reciprocal. Now that we have learned that the product of fraction and reciprocal is 1, we say let the reciprocal be M. You can as well suggest another letter. Teacher has opted for M. You say 2/3 times M is equal to 1, meaning a fraction times this reciprocal is equal to 1. 2/3 times M is equal to 1. So we multiply 2 by M, where 2 times M, you get 2M out of 3. 2M out of 3 is equal to 1. So where LCM is equal to 3, LCM is equal to 3. So we multiply this side and the other side by 3. We say 3 times 2M out of 3. 3 times 2M out of 3. 3 times 2M out of 3 equals 1 times 3. So we cancel by 3 ones by 3 ones. This side will remain with 2M, which is equal to 3. So it's the one we have here. 2M is equal to 3. Then divide both sides by 2. That is 2M out of 2 equals 3 out of 2. Where now when you cancel, M is equal to 3 out of 2. So that is the reciprocal. You say therefore 3 out of 2, or 3 halves, is reciprocal of 2/3. You see it has gone upside down like you wanted, but after showing the working, it has been 2/3, now it has turned to 3 halves, or 3 out of 2. So reciprocal is got by multiplying the given fraction by a letter which is equal to 1. The product of a number or a fraction and its reciprocal is 1. 2/3 times a letter M, which is the reciprocal, equals 1, is the one within which you work to find a reciprocal. Therefore, never just turn it upside down, much as you know the answer before the working is handled. So we go to the fourth operation of fractions, which is division of fractions. Division of fractions, and examples are here. The first example says divide 5 by a quarter. That's division of a whole by a fraction. So 5 divided by a quarter. You must note that any whole number is out of 1. If one told you to write 5 as a fraction, you would write 5 out of 1 like it is here. 5 out of 1 is the same as 5 divided by 1. So any number divided by 1 is that number. So 5 out of 1 is the same as 5. So but now, because we're dealing with fractions, let it be served with a denominator 1. So write 5 out of 1 divided by a quarter. And now when you are dividing by a fraction, we change the division sign into multiplication in the next step and reciprocate or write the reciprocal of the number to be divided by. It should be known that the number to be divided by is called a divisor. So let the divisor be reciprocated or written upside down. So we go, this 5 out of 1 remains 5 out of 1 times, this time 4 out of 1. A quarter changes to the reciprocal. The reciprocal of a quarter is 4, which 4 means 4 out of 1. 4 out of 1. So please change the division into multiplication, and then the number to be divided by, called a divisor, is reciprocated, is written upside down. That's why I first told you reciprocal for you to go division. I introduced the other reciprocal, which had earlier on been introduced in P.5, so that we go division well. So when I tell you reciprocal, you know what I'm talking about, for it has been brought to book here. So we multiply 5 by 4 and 1 by 1. As it is here, you get 20 out of 1, which 20 out of 1 means 20. So when we divide 5 by a quarter, or when you get how many quarters are contained in 5 wholes, you get 20 quarters. So the answer is 20. Because every whole has got 4 quarters. So now that's why we ended up having 4 times 5 and get 20 quarters in 5 wholes. In 5 wholes, 5 whole numbers. So then we go to number 2. Number 2 this time divides a fraction by a whole. Number 1 was a whole divided by a fraction, but number 2, example number 2, is division of a fraction by a whole. That is 3 quarters divided by 4. So you first give this 4 a denominator. I said 4 is the same as 4 out of 1. So you write 3 out of 4, or 3 quarters divided by 4 out of 1. Then the division changes into multiplication, and then the 4 out of 1 is reciprocated. So it's written as a quarter, or 1 out of 4. That is 3 out of 4 times 1 out of 4. Now we can multiply, since we don't have a common divisor. That 3 times 1 out of 4 times 4. That is the step here, and then 3 times 1. You get a 3. We have 4 times 4, you get a 16. Thereby getting an answer 3 out of 16, or 3/16, or 3/16. And that's the answer to that. And then example number 3 is about division of fraction by a fraction. That is 3 quarters divided by 3/5. So change the division into multiplication and reciprocate this divisor only. So 3 out of 4 remains 3 out of 4 times the reciprocal. The reciprocal of 3 out of 5 is 5 out of 3. Now we are detecting a common divisor 3. First divide here. 3 divided by 3 is 1, and 3 divided by 3 is a 1. You remain with 1 times 5 out of 4 times 1. It's the one that's here, where 1 times 5 is a 5, and 4 times 1 is a 4. But look at the outcome, which is an improper fraction. An improper fraction will never make a proper answer in mathematics. So therefore, we divide 5 by 4. Where 5 divided by 4, you get 1 remainder 1. This 1 makes a whole, and the other remainder makes a fraction. That's 1 whole number, 1 out of 4. 1 and a quarter shortly. 1 and a quarter is the answer. As we look at number 4, which is the last example to this lesson, please, it's in word form. Always read and then choose the appropriate operation to be used. Let's see what it brings to us. It reads, a bag contains 5.5 kilograms of maize flour. A bag contains 5.5 kilograms of maize flour. Okay, the question says, find the number of half kilogram packets. Find the number of half kilogram packets. that will be got or obtained from this bag, meaning it's going to be subdivided into halves. The content is to be subdivided into halves. Remember, the content is 5.5 kilograms. This bag contains 5.5 kilograms of maize flour. And now it's going to be packed or packaged into half kilogram packets. Then the question is, how many such packets will be got from the entire bag? So, like you have heard, it's going to be subdivided, meaning the division operation option is the best here. So you get our 5.5 divided into halves. That is 5.5 divided by a half. You convert 5.5 to improper form by getting a denominator times the whole number plus numerator out of denominator. Hence, we have got 2 times 5, which is a 10. 10 plus 1, you get an 11. 11 out of 2. Then times the reciprocal of a half, which is 2. 2, which 2 is out of 1. So you get 11 out of 2 times 2 out of 1. Remember, when division changes into multiplication, the divisor is reciprocated. A number to be divided by is called a divisor. In this case, the divisor is a half. It changes to 2 out of 1. And now we are detecting a common divisor, which is 2. First divide by 2 once, thereby remaining 11 times 1 out of 1 times 1, which is here, which is 11 out of 1. Which 11 out of 1 means 11. So the question is, how many half kilogram packets? We are going to have 11 such packets. So 11 packets, each containing half kilogram of maize flour. So that's how we apply the division operation in word numbers. And we've done all the 4 operations of addition, subtraction, multiplication, and division of fractions. And that marks the beginning of our workbook, which starts with a topic called fractions. And we have done those 4 operations. Please download and play over and over so that you can answer the first 8 pages. That's from 1 up to 8. All the work that is within that range, that is pages 1 to 8, can ably be answered if you read and followed properly this video without any omission whatsoever. I am teacher Katimbo Richard that has taught you this and taught you the first terms workbook. For more information about the same or the work we covered before or mathematics in general, call this same teacher Katimbo on 0776 25 1655. I repeat, 0776 25 1655. Alternatively, if you are on Airtel, do call this same teacher Katimbo on 07572 33066. I repeat, 07572 33066. Otherwise, it's the end of the lesson. Stay safe.